Hello, my name is Harmony and today I'll be speaking about epilepsy. Epilepsy is a group of neurological disorders that affects around 65 million people worldwide and is the third most common neurological disorder. When someone has two or more seizures, they are classed as having epilepsy. It affects the electrical and chemical balances in the brain and causes neuronal hyperexcitability, which leads to an electrical imbalance in the brain, which causes a seizure. There are many forms of seizures, including focal onset, generalized onset, and unknown onset. Depending on the type of seizure someone has, they may experience convulsive seizures, sensory disturbances, abnormal behavior, and loss of consciousness. The brain is made up of white and grey matter and has multiple sections of the brain that control different functions of the body. These include the brain stem, where all areas of the nervous system connect to the brain stem. It regulates heart rate, breathing, blood pressure, digestion, ability to sleep, and sweating. They also have reflex centers that control the body's ability to swallow, cough, sneeze, and vomit. The cerebellum controls coordination, posture, muscle tone, and balance. Finally, the cerebrum is the largest part of the body, the brain, and can be broken further down into lobes, including the frontal lobe, parietal lobe, occipital lobe, and temporal lobes. The frontal lobe controls concentration, memory, decision-making, judgment, emotional response, impulse control, language, voluntary movement, and consciousness. The parietal lobe controls touch and pain reception and the body's ability to know where it is in space. The temporal lobe is a lobe that is in control of what makes us us, including hearing ability, memory, interpreting language, some visual perceptions, and behavior. Finally, as the name suggests, the occipital lobe controls vision. The neuron is at the epicenter of cell communication in the brain and makes up the nervous system, and are responsible for transmitting messages at a rapid rate via electrical impulses. The neuron has three main parts: the axon, dendrite, and synapse, which is the space between a dendrite and another axon. Electrical impulses enter via the dendrite and leave through the axon. To aid in the transfer of electrical pulses through the synapses, neurotransmitters are used. When someone has a seizure, neuronal firing is altered, which can cause a change in the concentration of the neurons. Epileptic bursts contain sodium-dependent actin potentials and has calcium-dependent depolarizing potential. The voltage-activated calcium channels open, which allows for the neurotransmitter glutamate to enter the synaptic cleft. This activates the Chianti receptors, which creates an influx of the calcium and sodium ions through the channels gated by the receptors. This creates hyperexcitability within the brain. There is also a reduction of the GABA neurotransmitter. When a seizure occurs, the dendrite spines are damaged and are rewired incorrectly, which creates incorrect neuronal circuits that are hyper-connected, which are prone to seizures as they are susceptible to plasticity after an episode. Very little is known about cellular and molecular mechanisms that cause abnormal neuronal connections during limbic epidiogenesis. New research has found that in vivo rodents that have limbic epidiogenesis, that the phospholipid mediator platelet activating factor increases and the PAF receptor appellation migrates in progression. Platelet activating factor PAF is a phospholipid mediator, and its activity is done through a G protein receptor known as PAFR through the synaptic sites. PAF is responsible for maintaining neuronal excitability and can be easily damaged in a seizure episode. PAF modulates synaptic plasticity, and when the brain is stimulated, is synthesized at a rapid rate. When a seizure occurs in the brain, there is an increased uptake of PAF in the hippocampus, and the receptor PAFR is associated with neuroinflammatory signaling. Researchers found that synthetic PAFR antagonists LAU0901 and LAU0902 were administered into the peritoneum of rats and re-established correct dendritic spinal density in the hippocampus, which prevents the formation of deformed dendritic spines. The mice were evaluated 14 to 15 weeks after the PAFR antagonists were administered. The rats that were treated with the PAF showed reduced hippocampal interictal spikes, aberrant oscillations, and neuronal hyperexcitability. The researchers are suggesting that overstimulation of the PAFR signaling induces dysfunctional neuronal circulatory, which can facilitate epilepsy. Although this research is new and has not been studied on humans, the research is supported by the National Institute of General Medical Sciences of the National Institutes of Health, and future clinical studies would further evaluate the future application of the newly found LAU compounds in the treatment of epilepsy, as there is only treatments for seizures and not epilepsy itself. Here are my references, and thank you very much.